Forget everything you thought you knew about cars. The real battle in 2026 isn't electric versus petrol anymore. It's intelligence versus intelligence. Imagine a car that doesn't just drive, but thinks, learns your habits, makes decisions, and even entertains you like a personal AI assistant on wheels. Because right now, the companies winning the future of automobiles aren't building engines. They're building brains. Welcome to Jortiza, a community where we share insights into how technology and humanity is evolving. If you love excellence and want to think, feel, and see excellence in daily lives as we evolve, you are in the right place. Please subscribe, like, and drop your thoughts in the comment section below. Now let's dive deeper into this conversation. The future of automobiles is being rewritten as we speak. For the past decade, the conversation has been dominated by a single question: electric or internal combustion. But in 2026, that debate has become background noise. The automotive industry is now in what experts call the second half of its great transformation. And this time, it is not about what powers the wheels. It is about what powers the brain. We are moving away from the idea of a car as a piece of hardware that happens to have some software. Instead, we are entering the era of the software-defined vehicle, a smart agent that perceives, learns, and acts autonomously. At this year's CES, the pivot was unmistakable. Electrification took a backseat to artificial intelligence. As one industry analyst put it, victory in the automotive world will no longer be decided by battery range, but by AI capability. So, who is building the brains for this new generation of vehicles? At the forefront is NVIDIA. At CES 2026, they unveiled a massive AI model codenamed Alpamayo. This is not just a system that recognizes stop signs. It is a 10 billion parameter model designed to help vehicles reason through complex, unpredictable driving scenarios. This represents a fundamental shift. Instead of programming rules for every possible situation, which is impossible, these new systems learn to navigate the world like humans do, by understanding context and making reasoned judgments. This is physical AI, machines that understand the real world, not just data patterns. Uber has already partnered with NVIDIA, planning to deploy robotaxis powered by this new AI stack later this year. But this is not just theoretical. Real products are hitting the road. Motional, the autonomous venture backed by Hyundai, is pushing toward the most significant commercial milestone yet: a fully driverless Level 4 robotaxi service launching in Las Vegas by the end of 2026. The vehicle, the Ioniq 5 robotaxi, carries over 30 sensors, giving it 360-degree perception. But more importantly, Motional is moving away from the old modular approach where perception and control were separate. They are moving toward an end-to-end learned decision process. The goal is driving that feels natural, not robotic. Meanwhile, Sony Honda Mobility is taking a different angle. They unveiled the Afeela One, positioning it not just as a car, but as an experience space on wheels. The Afeela prototype is a luxury electric vehicle equipped with around 40 sensors, including cameras, LiDAR, radar, and ultrasonic systems, for advanced safety and autonomous driving features. With a 482 horsepower all-wheel drive system and a 91 kilowatt-hour battery, it delivers an estimated range of approximately 300 miles, with pricing expected around $89,900. It integrates Sony's entire entertainment ecosystem: gaming, movies, and AI personalization, turning the cabin into a digital sanctuary. It is a bet that in the future, the car's digital experience will be just as important as how it drives. But the AI revolution is not just changing the cars themselves. It is fundamentally changing how they are made. No company embodies this shift more clearly than Tesla. Inside Tesla's gigafactories, manufacturing is no longer a static assembly line process. It is a living, intelligent system. AI models continuously analyze production data in real time, predicting failures before they happen, optimizing workflows, and dynamically adjusting entire assembly lines with minimal human intervention. Tesla has even reimagined the physical structure of the automobile itself. Through innovations like large-scale casting, entire sections of a vehicle are produced as single pieces. The result: fewer parts, reduced complexity, lower error rates, and dramatically faster production. These are not just engineering improvements. They are decisions guided and refined by AI trained on massive datasets from both design and manufacturing. But Tesla's advantage extends beyond the factory floor. Every Tesla vehicle on the road acts as a data node, continuously feeding real-world driving information back into its AI systems. Through its full self-driving program, the company trains neural networks on billions of miles of driving data. The result is a powerful feedback loop, where the same intelligence that builds the car is also learning how to drive it. Under the leadership of Elon Musk, Tesla is not just producing vehicles, it is building an evolving AI platform. And if this model proves successful, the implication is profound. The cars of the future will not simply be manufactured, they will be trained. Luxury automaker Lamborghini is also embracing this transformation, but from a different perspective. Rather than focusing purely on autonomy, Lamborghini is developing what can be described as an AI driving coach. Using advanced sensor systems, the vehicle can interpret driver behavior, emotional state, and road conditions in real time. This enables a form of driver-centric intelligence, often referred to as emotional AI, where the car adapts dynamically to the driver. If the driver is tense, the system can enhance stability and control. If the driver seeks excitement, it can adjust torque distribution and handling characteristics accordingly. It is not just automation. It is personalization at a deeply human level. At the same time, Lamborghini is integrating AI across its entire product lifecycle, from design and engineering to production and change management, streamlining development cycles and improving precision. This highlights a critical truth. The competitive advantage of AI extends far beyond the driver's seat. It is transforming the factory floor and the design studio alike. No discussion of the automotive future is complete without looking at China. By 2026, China has solidified its position as a global technology innovation center. Level 2 assisted driving penetration in new vehicles has surpassed 60%, becoming standard even in budget-friendly cars. The competitive landscape is intense. Companies like BYD and Geely are pushing for global dominance, while tech giants like Huawei and Xiaomi are blurring the lines between consumer electronics and automobiles. If electrification was the first half of the automotive transformation, intelligence is the second half. And right now, China is defining its pace. While we see the products of today, research labs are already building the breakthroughs of tomorrow. There are 4 major areas driving this next wave. First is end-to-end AI, moving away from rules-based systems toward unified models capable of handling complex, real-world scenarios. Second is next-generation batteries. Solid-state batteries are entering early production, promising higher energy density, faster charging, and ranges that could exceed 1,500 kilometers. Third is in-cabin intelligence. We are moving beyond voice commands toward multimodal interaction, where vehicles understand gestures, eye movement, and context to anticipate user needs. And fourth is physical AI, where systems are trained in simulated environments that replicate the real world, enabling safer and more robust decision-making. Perhaps the most fascinating development is how automotive technology is becoming the foundation for entirely new industries. We are witnessing a phenomenon known as technology homology, the reuse of core technologies across different domains. Take Xiaoping Motors. They are developing humanoid robots powered by the same batteries and compute systems used in their vehicles. They are not just building cars. They are building platforms. Similarly, the race for flying vehicles, electric vertical takeoff and landing aircraft, is accelerating. Companies like Geely are exploring systems that share core technologies with ground vehicles. The automotive supply chain is evolving into something much larger, a backbone for a future where machines move in every dimension. However, this transition is not without challenges. There is a growing shortage of software talent. Traditional automakers excel in mechanical engineering, but software-defined vehicles require a fundamentally different approach, one built on rapid iteration and continuous updates. There is also the black box problem. As AI takes on safety-critical decisions, questions arise. How do we ensure transparency? How do we validate systems that learn rather than follow explicit rules? The industry is actively working to solve these challenges. The consensus is clear. No single company can do it alone. The future will be built on interconnected ecosystems, where automakers, technology companies, and suppliers collaborate at unprecedented levels. So, what does the road ahead look like? We are entering a stage of balanced reconstruction. The winners in this new era will not necessarily be the companies with the fastest cars, but those with the smartest platforms. For consumers, this transformation promises vehicles that are safer, more intelligent, and deeply personalized. Your car will know you. It will drive you when you do not want to, and it will entertain you when you do. For the industry, this is not just an upgrade, it is a reinvention.